Good morning, class. I am recording this so that you can watch it as a quick review with the sub while I'm gone. So if you will make sure you have out worksheet 9A and your calculator. See, I'll get my calculator loaded. We're going to go through this, and I'm going to go fairly quick. So if you need somebody to pause the video, if I'm going too fast, just have somebody come up and do that while you watch it tomorrow. Okay. So this is a review. There are several kinds of exponential and logarithmic equations you're going to run into. This says if a problem has a single power of x, this is strategy number 1. Notice these are not going to require logarithms, okay? So if it has a single power of x, isolate the power. So it's just like if you had 3x squared equals 27, you'd divide, you'd square root, plus or minus, blah, blah, blah. But this is powers that are rational, okay? So what we're going to do is use a reciprocal power. So first we're going to use our Algebra 1 brain to divide both sides by 15. We get x to the 2/3 equals 4. And then this really means the cubed root of x and then squared. So we could undo it in 2 steps if we wanted, or it means x squared and then cubed rooted. But either way, the fastest way is to take both sides to the 3/2 power, because when you multiply the exponent powers here, you'll get 6/6, which is just x to the first, equals, and then this is either 4 squared and then cubed rooted, or the cubed, nope, just kidding. This is 4 cubed and then square rooted, or it's 4 square rooted and then cubed. So this is 64, the square root of which is 8, or this is 2 to the cubed, which would be 8. So the answer is just 8. On this one, if we divide by 3 first, we get x to the 1.2 equals 19. Now, you could change this to a mixed number. It's actually x to the 1 2/10, which would be 1 1/5, which would be 6/5. So then you could do both sides to the 5/6, but it doesn't matter, guys. You could literally type 1/1.2 to the 1/1.2, and it'll work. That one, I don't know. It's going to be ugly decimal, I'm thinking, so I'm going to turn my calculator on, and I'm going to go 19 to the power of 1 divided by 1.2. You get 11.63. We'll go with 2 decimal places. If you had an older calculator, you would need to do 19 to the, and it wouldn't put the little box up there. You would just get the little caret. So you'd have to do 1 divided by 1.2 in parentheses. Okay, so if you don't get the little box, make sure you put parentheses. Whoa, what did I just do? There we go. Sorry. So I don't remember what we just had. I got sidetracked. 11.63. So either way, we get x equals 11.63. All right, moving on to strategy 2. If a problem has a single exponential, and that means that the variable's in the exponent, okay? Isolate the exponential and then take that log, and you can use either log or ln of both sides. All right, so the only x is in the exponent. So everybody get what this one is? The only x is in the exponent. You cannot multiply 50 times 3 because of the exponent. So you have to divide 3 to the 2x equals, And then 1250 divided by 50 seems like, oh, I don't know, I'm saying 61, but I should probably, or 7, I don't know. 1250 divided by 50 is 25. Yeah, I'm not even close. All right. Anyway, then we're going to take the log of both sides to get the x out of the exponent. So you can do log or ln as long as you do the same thing on both sides. And we're going to go over this today. So this will be day 2 on this idea. But you'd have 2x times the log of 3 equals the log of 25. Now you can divide in 2 steps or 1. Okay, I just brought the exponent out in front. That's an exponent property. So I can divide both sides by log of 3 and then divide by the 2. If I wanted to divide by 2 times log of 3 all at once, I'd need parentheses around the denominator. So I'm just going to divide by log of 3. So I get 2x equals, and when I type that, make sure you're closing your parentheses. So it's log of 25, close parenthesis, divided by log of 3. You could get by without closing that bottom parenthesis, but so 2.93. And then divide it by 2 still. And I get x equals 1.46. All right, please notice if you go back and try these, 50 times 3 to the 2 times 1.46, all in the exponent up there. This is not going to come out exactly 1250, okay? It's pretty far off, actually. And that has to do with the rounding, okay? If I went back and I did 50 and then 3 to the 2 times, and then I went up here and took this whole decimal, then I get 1250. Okay, so rounding makes a big difference in whether things are going to check here. All right, so this one we do 6.6, 0.5 to the x equals 0.8 divided by 6.6. Oops, I can't type. Now, I got an ugly decimal, and I don't want to do any more rounding than I have to. If I do a math enter, after I divide this, it comes out 4 over 33. You can leave the ugly decimal, but you should, actually what I should probably do is just leave it 0.8 over 6.6. And then when I take the log of both sides and I move the x out front, and then divide, which should have parentheses too, probably. I can just type it all in at once. That's a better plan. So I have the log of 0.8 divided by 6.6, close parenthesis, divided by the log of 0.5. And I get 3.0444 if I go out that far, or 3.044. The more places you have, the more accurate it'd be if you plug it in. Okay, 3.04 I would take, but it won't check very well. All right, the difference on this question, we're still going to divide by the 150 first. Get 600. But what you want to do, because it's an E, you could have been using ln of both sides this whole time and you'll get the same answers, I promise. But because this one is an E, you do want to do ln of both sides because you won't have to do as much dividing. Because when you put the 0.5x in front of ln of E, we're supposed to already know that the natural log of E is just 1. So now all I need to do is divide by 0.5. Now, the 0.5 doesn't divide into the 600. It still divides into the log. So we're going to type ln of 600 divided by 0.5. And I'm getting 12.794. And again, type it back in, but it's not going to come out exactly 90,000 because we rounded. All right, moving on to the third possibility is if we have a single log expression, then we're going to isolate and either exponentiate or rewrite. Okay, so a single log. So this currently says log base 10. So I could think about rewriting it. Base to the power equals the number. Okay. Some of you learn it as exponentiate in Algebra 2. In other words, you put both sides to the 10. You rewrote it like that. And then these undid each other. So you had 2x plus 20, and this became 10 to the third. It's the same thing. All right, 10 to the third is 1,000. So I'm going to assume you could solve that. Subtract 20, divide by 2. Okay. On this one, you would divide by this 3 first. So you'd have ln of x plus 2. When I divided this side by 3, I'd get 2. Now, ln means when we exponentiate, we're going to use e on both sides. Or if you rewrote it, you'd think of it, it's ln base e of x plus 2 equals 2. So you'd have e to the second power equals x plus 2, which is exactly what I'm going to get here because these wipe each other out. Okay, so an exact answer here would be e squared minus 2. All right, if you wanted a decimal, e squared minus 2 is 5.389. Okay, and the fourth one, the fourth possibility is a problem can have several log expressions. We're going to compact them, and then we're going to use one of the patterns above. If it has a log on both sides, we can eliminate the log on both sides. If it doesn't, we're going to have to rewrite or exponentiate. What am I talking about? Well, on this problem, adding 2 logs means we can rewrite as a single log multiplied. Okay, that's the whole compacting thing. And I have equals 3. Now there's only one logarithm, so I can either rewrite with a base 10 or I can exponentiate both sides, whichever way you like to think of it. We'll get 2x squared equals 10 to the third. All right, this is 1,000 divided by 2 is 500. I skipped some steps there. If we square root both sides, I could give an exact answer. That's 100 times 5. So I'd get 10 square roots of 5. Or if I do square root of 500 as a decimal, I get 22.36. Either one is fine with me. This question is different because we're going to have logs on both sides. But first we have to figure out how to compact this. Okay? You can't make this division until you get rid of this 2. That guy needs to move up there. So now I have ln of x squared minus ln of 3. Now the minus becomes divide. Okay, and then we can use, because there's a single log on both sides, we can use the one-to-one property. Says the only way this is true is if x over 2, x squared over 3, has to equal 12. Then we get x squared equals multiplied by 3, 36, square root. and we get plus or minus 6. The problem is, back in the original problem, okay, way up here, I had ln of x. Can I take the natural log of negative 6? Is there such a thing as e to some power that would become negative 6? The answer is no, can't take a log of a negative. All right, so the answer will just be x equals 6. There's an extraneous solution. Okay, so you have to be really careful with negatives. That's not to say a negative will never work. There are definitely times when negative would work. If we had the ln of 1 minus x equals 7, okay, a negative number in here, 1 minus a negative would become a positive, so it'd be all good. All right, so there's situations where you can have negative, just have to check if it's going to work when you plug it back in. All right, I'm just going to do the first step on this, or the first couple steps. This you would divide. This is just more practice combined of all the ones up above. So I'd have e to the 0.2 t equals, I'm just going to leave this because I'm too lazy to even type it in. I take the ln of both sides, which would bring this down in front. So then this is 1, and I need to divide by 0.2. And I'd get an answer. All right, moving on. I would divide both sides by 4. So I'd have x to the 0.4 equals, and I think I'll just leave this one even. Then, because this is a number, not an x up here, I'm going to do the reciprocal power. And you can change it to a fraction and find the reciprocal, but I could also just type 1 over 0.4. So I would type this into my calculator and get my answer. These are the two I want to revisit because this is the one we didn't do very many of. Plus would mean you would multiply, you want to compact these into a single log. And then because you have a single log on both sides, the one-to-one property says 3x has to equal 48, so you'd get x equals 16. This one you would divide both sides by 3 first. And then you would, like I say, either exponentiate or just rewrite. This means 10 to the power equals the number. So this is 100. To get rid of divide 2, I multiplied 2, and I get 200. All right, I know I went really fast, but the idea is you're to work today the rest of the time on finishing up page 171, working on page 196, working on page 167, and some of the problems on 5AB. I'm sure there's still some problems on 5AB that you're going to have questions on, but that's what tomorrow is about. Okay, we're going to do Newton's Law of Cooling tomorrow, and then other than that, I want homework questions ready to go. Homework check Friday.